Good morning, good day to Pa Abdul Muiz, who's currently seeing this. My name is Jessalyne Desiree Putri Bertua Simanjuntak from the Electrical Engineering major international program batch 2022. And today I'm gonna explain to you about my final project, which is this solar panel monitoring system. All right, so I'm gonna explain. As per the paper and proposal, we're gonna have three main features. First of all, which is external interfacing with components. Second is using the web server, and third is using deep sleep. So first of all, we obviously need external interfacing with components, right? Because look at it, there are a lot of components. Like there's the LDR sensor, the temperature sensor, and the current sensor. And in order to make all of this work and make the ESP32 control this and all of this works correctly, is to interface it. So how do we interface it? First of all, we need to define the pins, right? First of all, we define the LM35 pin, and then the current sensor pin, and then we have a wake up pin, which is supposed to be a button, but there is no button, and I'll explain later. So we also define this liquid crystal I2C, and we also have its respective library, and then we also add these variables. That's for the LDR to calculate the light intensity. All right, next is that we set this up. So we define all of the defining things in here in the void setup. And then how to interface it even more is that we look at the void loop function, and then we have each each operations for the corresponding variables like temperature, current, and light level. All right, that's one feature. The other feature, you've probably seen it, but it's basically the web server or Wi-Fi. So we're using this ThinkSpeak website, which is also an interfacing website like Blink IoT that interfaces and visualizes data read from the sensor using graphs. So like this. All right, yeah, this was like the readings I did in the later part of the video. So in order to make this work, we do this. We have a defined channel ID and defined channel API key. And why do we need this? Is basically to connect the ESP32 to the ThinkSpeak cloud server. That's why we also have constant char server, API thingspeak.com, and we also need to connect it to a Wi-Fi. Please do not copy this. This is for educational purposes. All right. So, a thing to note is that you should only use 2.4 gigahertz Wi-Fi instead of a 5 gigahertz Wi-Fi. So because the ESP32 is only compatible with 2.4 gigahertz, and that's why there's the 2G Wi-Fi. All right, and then the last feature we have is, forgot to mention. Next is how to connect to Wi-Fi. So this is how to connect the Wi-Fi basically. So we've added a library which is wi-fi.h, and this basically integrates connecting the ESP32 to the Wi-Fi. And this is these are like the commands, and this is what you see basically in here, connected to Wi-Fi, so that it signals, the ESP32 is connecting to Wi-Fi. All right, this is if it fails. Next, lastly, we have the deep sleep. So deep sleep is triggered by a button, and unfortunately, due to unforeseen circumstances, we do not have one here, and we only have this. So I think I will explain it later, but so this is to simulate a button. If you put it in here, it means that the button is pressed, and the button is pressed, and then this wakes it up from the sleep. But if you connect it to the ground, it's in deep sleep. And basically, the only thing you need to do to configure it is just this ESP enable external wake up, and the only thing to execute it is by doing this. Yep, this one. All right, that's all for the features, and I will see you in the next part of the video. Okay, hello, I'm Jessie, and I'm gonna test my project about solar panel monitoring system outside here. Here's the setup. This is the circuit, and this is the solar panel and the load, the floodlight as load. So currently it is around 30 degrees outside here, and so I'm gonna upload this code first. Gosh, where's the upload? But okay, I'm uploading. The cable. Okay, plug the cable, and then we're gonna upload again. All right, so okay, this should be working. The LED is there. All right, and there seems to be some data here, right here. Okay, wait, it's kind of cannot see. Okay, there's kind of a data here. All right, it's running, and just need to wait. Where's the cursor? Oh, here it is. Okay, so as we can see from the serial monitor, it has successfully uploaded, and alright, so all we need to do is just wait until all we need to do is just wait, and here we can see that the floodlight is already on. That's because it's getting current from the light that is from the solar panel, and we can see from the graphs, yep, there seems to be an increase and decrease in light intensity. Might be because that the cloud moves, and like it's sometimes sunny, it's sometimes cloudy. So yeah, this is, oh, hold on a sec. Yeah, to zoom it in. All right, okay, there it is. Yep, this is what I mean by it's fluctuating per se, and this is the temperature. This might be inaccurate, but I will explain it later. Probably have to explain it in the paper, and I'll explain it later in a later part of the video. All right, so yeah. Okay, another point here is that there is this button pressed waking up from deep sleep thingy. It's to test whether the deep sleep works or not, but unfortunately the button is nowhere to be found. So like we simulate a button by like plugging in sorting the wake up button pin to the ground so that it simulates that there's a button to be pressed, and yeah, that means that the deep sleep works. And actually, if we don't press the button, in which we unplug the button connected to the wake up button pin, this data, it won't show up. All right, so let me simulate it. No, actually, so like I'm gonna just unplug this one, right? And so, all right, so my bad. So the button was originally here, and if we put it in ground, it simulates that the button is not pressed, and that means the deep sleep. This thing will be entering to deep sleep. Yep, it's button not pressed, entering deep sleep, and that would mean that there's no data. This thing stops. Yep, there is no data right now. So in order to put it back on again, you just need to remove the button from the ground, and then yep, we plug it in. And so the button is pressed, waking up from deep sleep, and there should be data reading in here. Okay, so next I'm gonna explain about the technical difficulties that we faced along the way. So first of all, actually we were not gonna use these same solar panel and floodlights, but instead we were gonna use a smaller solar panel, which is technically cheaper than this one, and we used an LED to light it up. But unfortunately, the first solar panel, hang on a sec. All right, so this is the original solar panel that we were about to use. So we can read from the description here. The maximum power is 5 watts with the maximum voltage at 17.6 volts, but that would only make a current at Pmax at 0.29 amps, and that is actually way too small. And actually I didn't use that one either, the current sensor. That is a 5 amps current sensor, but instead I used a 30 amp current sensor, which also didn't help that it was put in a pack. It was only put in a box, whereas this one came with a sponge on the pins, so that probably the 30 amp sensor was broken on the first try, and this one didn't, because like it was protected. And also the reason why we bought this 5 amp sensor instead of buying another 30 amp sensor was because that the current that we're reading is probably still too small for a 30 amp sensor, so we opted for the 5 amp sensor instead. And then alright, so as I was saying, instead of using the smaller solar panel, we used the bigger one, which is I believe it's 12 volts, 12 watts, 5 volts. Yep, 12 watts, 5 volts. And then the tricky part was actually to reconstruct this whole thing. So my dad and I, we we unbolted this whole thing, which was also hard, and we tried to see if there were batteries in it, right? And so we saw the internal workings, and it says that, and we concluded that if we plug this into like a power source, I mean technically this is a power source, it would charge, right? And then it would turn on and off with using like a remote, right? But this was quite a challenge because like we had to figure out which pins belong to which, and how we should like connect it. And so yeah, I believe that is like the end of the vid. I believe this is all from me. Yeah, thank you for watching.